Okay, so today we're going to talk a little bit about Module 4, Lesson 4. It's on rates, ratios, and proportions. We're going to start with talking about what a ratio is. So a ratio is just a fraction that we make with a couple of different values that typically have units on them. Sometimes the units will be the same, and then sometimes they won't. Let's get a couple of examples of both. If I ask you to write a ratio for a statement like this, so 6 miles per hour to 18 miles per hour, all we're going to do is we're going to take these two values and we're going to make a fraction out of them. And in this particular problem, my units are the same on both of them. So if I put that in, 6 miles per hour over 18 miles per hour, those miles per hour, we can just kind of cancel them off since they're identical. And we can write our final ratio unitless. But what we can't do here is we can't just stop with 6 over 18. We do need to take it's a fraction. So like all fractions need to be reduced to lowest terms. 6 and 18 both divisible by 6. So 6 divided by 6 is 1. 18 divided by 6 is 3. And so 1/3 is going to be my answer here. So because my units are the same, I don't need to put any units on my ratio here at the end to finish it up. Okay, I could have a problem like this instead, where it's 12 inches to 5 feet, for example. Okay, and if I was going to do that, I'm going to start the same way. I'm going to take my 12 inches, I'm going to put it on top, and my 5 feet, I'm going to put it on the bottom. I'm going to try to reduce my fraction down to lowest terms, and then I'm just going to stop here. Since my units are different on the top and bottom, I'm just going to leave it with two separate units, and they're not optional. When our units are different, we do need to keep those in there. Okay, we use these ratios for a lot of different things. Like if I said I was going to go 300 miles in 5 hours, okay, we can write a ratio for this. So 300 miles will go on top. 5 hours will go on the bottom. We reduce this down. Well, 300 divided by 5 is 60. Okay, and miles on top and hours on the bottom. When we have a setup like this, what we're doing is we're making a rate. And we generally use the word per in situations like this, and you hear this all the time. You get this, you get 60 miles per hour. And so we use these ratios to get speeds like this, and we use these all the time. So very, very, very common in everyday use. You might be asked to write a ratio that some of your initial values have some decimals in them. So let's say we want to write a ratio for this situation, 7.3 to 10. Okay, what we're going to do is we're going to start the same way. We're going to put that 7.3 on the top and that 10 on the bottom. But we never want to leave a fraction like this that has a decimal inside of it. So in order to deal with that, what we're going to do is we're going to take our decimal on the top, we're going to slide it over to the right. And if we do it on the top, we have to do that exact same thing on the bottom as well. So I'm going to slide that over, rewrite this as 73 over 100. Next, I'm going to try to reduce this fraction down to lowest terms if I can, but in this particular problem, there's nothing in common than those terms, so 73 over 100 is going to be our answer. We can also take these ratios and make statements out of them that have equal signs in them, where we have a ratio on the left and a ratio on the right. We call this a proportion. So kind of in general, it's going to look like this. A over B equals C over D, ratio on the left, ratio on the right, equal sign between them. Okay, these are very useful for making comparisons, and we use them in math quite often. Okay, and the nice thing about them is we can get this thing called a cross product from these ratio statements. Okay, and so if I go across this way A times D, I'm going to get my first cross product. And the nice thing about this is it's always equal to what I get when I go across the other direction. So B times C is what I get for that one. So these two cross products are going to be equal, and very often when we start with problems like this, we can find these cross products and just get rid of the fractions immediately. Let me show you what I mean. Say we have a problem like this, 5 over 8 equals x over 16, and we're trying to solve for x in this problem. Well, the way that I'm going to do that is I'm going to find the cross products, I'm going to set them equal to each other, and then I'm going to solve for x. So I'm going to go across this way, get my first cross product, 8 times x is 8x. I'm going to go across this way, so 5 times 16 is 80, and my fractions are gone. Very quick and easy way to eliminate the fractions when I have this sort of proportion set up. I'm just going to divide by 8, and so my x value is 10. Okay, so pretty quick and easy way to eliminate the fractions, work from there. It's not to say that the fractions won't come back at some point. Let's look at one where we do have some fractions at the end, but we are still going to start the same way. So we have a proportion again, so 3x over 7 equals 9 over 2, and we're just going to eliminate the fractions right off the bat by cross multiplying, getting these cross products. So 7 times 9 is 63, 3x times 2 is 6x, okay, and then we're just going to solve for x, so we're going to divide by 6 on both sides, get rid of those, and then 63 over 6, I do need to take a second because we're going to get a fraction here. 63 divided by 6 is not an even number, okay, and we do want integers or simplified fractions for questions like this most of the time. So we won't want to reduce this down to lowest terms. It turns out here that 63 and 6 both divisible by 3. So we'll take that out. 63 divided by 3 is 31. 6 divided by 3 is 2. So 31 over 2 is what we want there. Okay, so we can certainly use these ratios to solve problems. This is what they're most commonly used for. This particular problem, it tells us here that the weight of an object on the weight of an object on Earth, the ratio of an object on Earth to the weight of that same object on Pluto is 4 to 11. So I can use that and I can make a ratio out of it. So 4 over 11 is going to be my ratio there. Okay, and what I want to do when I'm doing problems like this is I want to take a quick second to note what these numbers represent, because when I'm setting up a proportion to solve problems like this, what's important is that you're consistent with how you set it up. So 4 over 11, the 4 is the weight on Earth, okay, and then the 11 is the weight on Pluto, okay, and so it tells me here that an object weighs 500 pounds on Earth, right? I have to be consistent. I have to put that 500 on the right side of the fraction bar, and because it's a weight on Earth, it has to go on top. Okay, and then on the bottom, I'm going to be looking for the weight on Pluto, so that's got to go across from there. So again, the key thing here when you're setting up these proportions is that you're consistent with how you set it up, okay? And so once we get to this point, it's just a matter of cross-multiplying. The solving is pretty easy as long as you can get these things in the right order, right? We're just going to multiply across the top. 4 times x is 4x. And we're going to multiply across the bottom, so 11 times 500 will give me, just put it in your calculator here, 5,500. Sorry. Okay, divide by 4. And again, just to calculate a problem, I would say just don't need to round for this one. It comes out even at 1375. But you do want to pay attention to your instructions in problems like this, because sometimes you will have to round. You might get decimals. I mean, this is the decimal module, so it's very possible. Okay, another skill we'll need to work on in this section is we need to be able to find these things called unit rates. Okay, basically what we're going to do here is we're going to figure out what the rate is, or what the cost is, or the calories are, or whatever for one object. Okay, so if we're given a situation like this, again, this is a really common practice. Like if you look on the back of most food items, you might see the calories per ounce, or the saturated fat per serving or things like this. All of these are examples of unit rates. We definitely use these in everyday life. And so for this one, 315 calories in a 3-ounce serving, what we're going to try to find here, if we're finding a unit rate, is the calories per ounce. Okay, and we're just going to take our calories, which is 315, and we're going to divide it by the number of ounces, and our units are going to be calories per ounce. Okay, and so we're dividing, and then we're putting this in our calculator and working it out. So 315 divided by 3 is 105. Works out nice and evenly this time. And often when you have that word per, you can write the word per out. You can also sometimes use this little division sign slash here to show that it's the calories per ounce there as well. So that's the idea on that, for finding a unit rate. Okay, so this situation, we know that we spent $138.40 for 8 pizzas. We want to calculate the price for one pizza, also known as the unit rate for this situation. We're just going to take our total price, which is $138.40. Okay, and we're going to divide it by the number of pizzas that we have, and then our units are going to be dollars, because that's my top units per pizza. Because that's what we're doing when we're finding these unit rates, is we're finding the price per for one, basically. And again, at this point, don't make this more complicated than it is. Just put it in your calculator. 138.40 divided by 8, since we had the 8 pizzas there, and we'll get 17.3 is what our calculator says. But because we're talking about money, I'm going to go ahead and put it to the nearest cent. So put that 0 on there. Because, that's how we work with money, is with 2 decimal places like that. Okay, so hopefully that's helpful with getting y'all started with Module 4, Lesson 4. Please let me know if you have any questions.